All right, and we are ready to start. Welcome. Working on lesson 10 today. Do we want to start with, did anybody have any specific questions on anything we can go over before we delve into the prep assignment?
I've just started doing the prep and going over the review and everything. Since I had to work yesterday, this is my day off, so I'm just now getting into the math. So anyways, as I was reviewing it, I think I was having problems trying to get the upper confidence interval formula. I got the lower one, but I didn't know how they were getting the upper one.
Okay. Let me look.
Are you talking about the plus and minus thing?
Yes.
Okay, so one of the equations is going to be minus. So you do you put in all the same numbers and it's minus.
Oh, and then you just do plus for the other one?
Yeah.
Okay.
Yeah.
Okay, got it. Because I was doing plus or minus
so
sign.
Yeah.
Good.
So to get the two ends,
So like
you add on one side and then you subtract again.
Okay, got it.
Yeah. And then you'll put those two answers in parentheses.
Right. Okay, got it. That's as far as I got.
All right.
Yeah, because on the thing it said plus or minus.
Yeah.
I got it.
And it says that because you need both ends.
Right.
So in the chapter when it's talking about like election results and stuff, that's where I kind of understood it better, was reading that section in the book.
Okay.
And it talks about the likelihood of like the politician winning the election, but then there's going to be that margin of error.
Right.
So plus or minus, and it says that their intervals both overlap, so you can't determine between the two. So that was a good section in the book to read.
Yeah.
If you want to go over that part, I found it really helpful in starting to understand it.
Okay. Yep. That's as far as I got though on the homework.
Okay. Let me look at. So you got through number 3 then on the prep assignment?
Yeah.
Okay. Do we want to just go over the rest of it then and see if anybody has any more questions? Okay. So for number 4, what are the assumptions for creating a confidence interval for a single mean with the sigma known? So I got that you have to find the simple random sample, and then you need to know the distribution mean, so that you know that it's normally distributed. And then you have to also, as it says in the question, sigma has to be known.
Yeah. Yep.
Okay.
And I get my like symbols and what they actually mean. Sigma is standard deviation, correct? Or do I have it mixed up with it?
Okay. If I remember, sigma is standard deviation of the population, right?
Okay. Yeah.
And then X bar. See, X bar is the one that I get a little mixed up on. Is X bar supposed to be the mean of the sample population or the standard deviation?
It's the standard deviation. The S bar, the S with the bar or the S without the bar? Just
X bar.
Oh.
X bar? Oh. Is that what you're talking about? X bar
Yes, yes.
is the mean of the...
Yep.
See, all the symbols. That's what's going to get me.
Yeah, I
But
gotta
know
write it down.
that mu is the sample population mean.
Okay, that's what I was thinking it was.
And then
well, mu. Wait, what is mu?
mu, from what I understand, is the population mean. So then X bar would be the sample mean.
Yeah. Okay. I knew that. I just need to make a list and just put down each symbol
Write it
and
all
write.
down.
Yeah, you gotta write all these.
I'm thinking of that. So then, what's the symbol for like sample standard deviation? Is there one?
I do not know. We probably have a symbol for it. It's just, they all get so mixed up sometimes.
Yeah.
That was last semester, or wasn't last chapter.
Just make Google really quick. Oh, it's S.
It's S.
S. S is sample standard deviation.
Right.
I actually found if you want, I can send you to this this web page really quick. It's got all of the symbols in it.
And what they stand for.
Yeah.
Oh,
That would be great.
What is that?
It's called rapidtables.com. If you want, I'll just email it to you.
Okay.
That would be great.
Yeah. I love.
All right. Are you guys ready to go over number 5?
Yeah.
Yeah.
Okay. So, basically we're finding the positive z-scores just on the applet
Oh, I got that.
for this one.
We put in 0.9.
So,
I thought it was pretty self-explanatory. It wasn't that hard.
yeah.
You just gotta remember what it needs to be.
I got 1.
Remember to shade in the middle.
Yeah, shade in the middle. It's 1.65.
Yep.
.95 in the area. Oh, these are easy. You just so it's 0.196 because you round up, right?
Yeah.
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 That's what I keep forgetting to do.
Yeah. C was 2.58. Right.
Yep. That's what I got.
Yeah.
And then 0.99 is 2.56. Yep, 2.56.
For which one?
If you type in 9.99, it's 2.56. For C, I think it was C. 2.58 actually, to round up.
Yeah, it's 2.58. And then for D, I got that
It
as
increases.
the area.
It goes up.
The z-score is going to increase as the area increases.
Part 2, on A, it was saying like what's the point estimate for the population mean?
For which number?
A on 6. Is that having to do with like I found something in the book? It's towards the bottom. Okay, so if x bar is within 2 standard deviations of mu, then mu is within 2 standard deviations of x bar. So is that saying then that the population sample is the same as the, or sorry, if the population sample is like 2 standard deviations and so is mu, so then like if this number is population sample, then if the sample population is this number, then is it saying that the population number is not? You understand what I'm saying?
Kind of. I think I know what you're talking about, but it just what is it called? Takes me back to when we were studying the law of large numbers. And let me look it up really fast. Because that talks about, I believe, if it has to do with the sample mean and the population mean being the same. I can't remember the exact wording on it.
Okay. Is it? Then it's 541 with the sample mean being 541. It's a large enough sample. Should be the same number then.
Right. Sample mean for these 50 students is 541. The point estimate for the population mean is 541. Maybe 95%. Okay. Calculate.
Yeah. So what I was talking about with the law of large numbers is that as the sample size grows and gets larger, the mean of the sample size is going to get closer to the
Population.
average of the entire population.
Okay.
So I don't know if that helps.
Okay. Well, when you say closer, it's going to be like closer to the same number that the population size is? Okay.
Yeah.
Okay. So with 541, I mean, sample mean for this sample is 541. That's a pretty dang big number. So it would pretty much be the same then, right?
Let me just read it really fast. Sample mean. Yeah. Because the sample size is large enough, you're going to assume that the population mean is the same as the sample mean.
Okay. Okay. That makes sense, though, because they say that once, if it's 30 or greater, it's considered to be normally distributed. So, it should mean that it's really close to being true, or to the correct numbers. Okay.
Okay.
For number 8, I've got 532.13 and 549.87.
Yep, that's what I got.
Okay. Once you do these a few times, you get used to it. It gets easy.
Yeah, I think that's the biggest thing is just the more you do it and the more you practice it,
Yeah.
the simpler it gets, the less confusing it seems. Because when you have like 1,000,001 symbols and numbers thrown at you, it's a little confusing at first.
Yeah.
I always just forget to do the square root first. Okay, so that's 10.
And then for number 9, I got 534.73 and then 547.27.
Yeah. Yep. That's what I got.
Okay. And
Yep. That's what I got.
okay. And then for number 10, I got that the margin of error gets smaller as the sample size gets larger.
Okay, and then so to find that one, you're using the formula m equals 2 with sigma divided by n squared, right?
Yes.
Okay, so then you're taking over standard deviation here. Okay, so you're taking 32 and putting it in place of sigma, and then are you taking 50 and putting it in place of square root of n?
Yeah, because that's your sample size.
Yeah. Okay, and that's how you find your margin of error.
Yeah, you want to find your margin of error when the sample size is 50 and 100, and you compare them. And your margin of error is going to be smaller as the number is larger.
Okay.
That's easy enough then.
Mm-hmm.
Okay, and then it's just look at the sample size first. It says 15 clients, so that's already under 30, so we can assume that.
Sorry, can you say that again?
Sorry, can you hear me okay?
Yeah, you were just breaking up for a minute there.
Okay. So on 7, it's asking, are the requirements for creating a 95% confidence interval met? And so it would be no, because the sample size is only 15 people. It's not 30.
Which one are you looking at?
At 7?
At number 7?
On the preparation assignment.
Okay.
It says a study by the National Association of Realtors reported in 2004.
I'm not finding the question.
Yeah, I'm not either. Number 7?
Yeah, it's underneath.
Because numbers. Because 7 talks about population mean.
Hold on. Yeah, less than 10 preparation.
Oh, the other preparation assignment. There are two.
Oh,
Oh, I see which one you're talking about.
Yeah.
You switched assignment though on us.
Am I looking?
You're looking at the other one. Because there were two prep assignments listed.
Okay.
And so the one we were going over is not the one you're looking at right now.
Alrighty.
So let's finish the first one we were looking at, and then we can switch over to the other one and go over that.
Alright.
we're around number 12.
Yeah. Actually, let me just check my numbers for number 11 with you. For the 90% confidence interval, I got 533.56 and then
Yep.
548.44.
Right, that's what I got.
Okay. Okay. So for number 12, what I saw was that when the confidence interval gets smaller, the margin of error gets smaller as well.
Right. Okay.
Because the margin of error for a 95% confidence interval, I got 8.87,
And then
and when it was 90,
7.
yeah.
It went and got smaller. Yep.
Mm-hmm.
Okay.
And then for number 13, I got 158 students. Because you have to round to the nearest whole number. You round up.
Guess I'm trying to figure out how you got that 158.
So, there is an equation for it. Let me see. Where is it in the book? Oh. So, in the book, it gives us, it's called sample size formula, which helps you obtain like a specific margin of error. So the equation for it is, so it's going to be your sample size is equal to your z-score times your standard deviation over the margin of error that you want, and then you square that entire.
Okay.
You square it.
157.
Yeah, you get 157.3, but you with that you always round up to the next whole number.
Okay.
And then you want to look at number 7 on the other prep assignment?
Yeah, I assumed that was part of what we needed to do.
Yeah. Okay. I feel like we had this question last week when talking about the realtors.
After that, though, it's got
Let's see. So for part A on 7, are the requirements for creating?
Yeah.
I would say no, because the sample size isn't large enough. Because you need at least a sample size of 30 to assume for it to be normally distributed.
Yeah, it's not greater than 30. It's only 15 people.
Mm-hmm.
Okay.
For the 95% interval, I got 44.2 and 49.3.
Yeah.
And then for the 99%, I got 43.4 and 50.1.
Yeah. All right.
Okay, I'm lost. I don't know where you guys are at.
So there were 2 preparation assignments.
Yeah, I only see one. I don't see the other one.
Posted under, if you go on to lesson 10, individual preparation, if you go under there, it has, where it has the preparation assignment and answer key, there's a 3rd document as well. And that's what we were working off of.
Okay.
All right, did anybody have any other questions or anything before we move on and do the quiz?
Nope.
I think I got it all.